The CLO for this lesson is that students will be able to create, in writing, equations using linear equations, slope, y-intercept, parallel and perpendicular lines, as well as the following language. If-then statements, linear, slope, y-intercept, parallel, and perpendicular. Sure, let's start with the vocabulary. I didn't put these three because we know them. What is a linear equation? What is slope? And what is the y-intercept? So the two new words are parallel lines and perpendicular lines. And that's what the notes are about, parallel and perpendicular lines. So two parallel lines are two lines that never cross. So they are running in the exact same direction forever and ever. Watch. Parallel lines. If we look at images, it's like this. They never cross each other. They're always the same distance apart, so they never end up crossing. Versus two perpendicular lines, they do cross. Not only do they cross perfectly with 90-degree angles in every corner. So two lines can cross non-perfectly. Like this. This is not a perfect cross at all, where they're crossing right now. A perfect cross looks like this. It's like a straight side to side with a straight up and down, and it's a little 90-degree corner where you could put a perfect square in like all four corners because they're all 90 degrees. So like here's more examples where they're crossing perfectly. So even if you spin this around, like this is kind of when it's spinned, as long as each corner is a 90-degree angle where you can put like little squares in them, perfect little squares, then they're considered perpendicular lines. Here's a picture of two parallel lines. So we're going to start with the first one, parallel, two lines that never cross. And here's a picture of them. Well, let's figure out their equation. To do that, we're going to call one of them line 1 and one of them line 2, and we're going to figure out their equations. So let's go ahead and call the dark blue one number 1. So equations are always y equals mx plus b. So if I start with the slope, I find one perfect point. Here's one. And the next perfect cross seems to be right here. So to go from the left point to the right point, I'm going to go down 1, 2, 3, and then to the right 1, 2. So I'm going down 3, right 2. So my m, my slope, is down 3, right 2. And then plus my b, my starting amount. Well, I'm crossing the y-axis right here at 1. So my y-intercept is plus 1. So that's this equation. Now we're going to do number 2. So right here is a perfect cross. And so is right here. So starting from the left point, I'm going down 1, 2, 3, and then to the right 1, 2. So down 3, right 2. So my equation is y equals, and then for my slope, I'm going down 3 to a negative 3, and then to the right 2. then x, and then plus b, and my b is my starting amount, and I'm crossing the y-axis at 7. So these two lines are parallel, and you can tell by the picture because they don't cross. What do you notice about their equations? What do they have in common? If you look, the slope is the same. And that's the reason why they don't cross, because even though they're starting at different points, this one starts at 1, this one starts up here at 7. For both of them, from where they start, they're going to go down 3, right 2, down 3, right 2. Therefore, they're never going to end up crossing because they're growing in the exact same way, which is why they never cross. So parallel lines never cross because they have the same slope. And that's the important thing about parallel lines. So a question might be, create the equation of a line that's parallel to, and they give you an equation. Well, the answer is any equation in the entire world that has the same slope. So it has to be -2 as well. But it can be any b you want. It could be +5. It could be -10. As long as it's not the exact same one, the lines are going to be parallel. And you can test it. -2x minus 1 is going to look like that. And then -2x. And these already are parallel if I didn't even add anything at the end. But I could put +5 if I wanted to, and it just separates them apart a little bit more. So that's slightly different though if they do tell you that it needs to go through a certain points. So this is the exact same equation, and it wants a parallel line as well. But then it says passes through the point 5 comma -2. Well, when that happens, that means that you have to have a specific b. So to figure out what that b is, you plug in the point to find the b, just like in the other ones. So basically it's giving you the slope because it's telling you it's parallel, and then it's giving you a point. So when you have a slope and a point, you take it. Remember, f of x is the same thing as y. And then you plug in the x into the x and the y into the y, and you solve for your b. So -2 times 5 is -10. And then what do I do to solve for b? I add the 10 to both sides. -2 plus 10 is 8. -10 plus 10 eliminates because it's 0. And so 8 is b. So the equation of this parallel line that passes through that point is -2x plus 8. And if I show you -2x plus 8, it's still parallel to this line, but it definitely goes through the point at 5. It's the answer is -2 down here. So it goes through the point we want, and it's parallel to the first line they gave us. So the second word that they want you to care about is perpendicular. Remember, perpendicular cross in a way where you can make perfect little squares in all 4 corners. So let's figure out the equation of both lines. So let's call the orange one line 1. So I need to pick a good point. Here's one right here, right where that arrow hits. And then these are all decimals all the way till where they cross right here, because that's a good point. So for my slope, I'm going down 1, so it's -1, and then right 1, 2, 3, 4, 5. So my slope for this one, I'm going down 1, then right 5. And then plus my y-intercept. Where is the orange line crossing the y-axis? It's definitely a decimal. That's less than half. Maybe it's like 0.3. If you guessed 0.2, 0.3, anything like that, it would work. Well then, for my equation for line 2, it's y equals slope x plus b. So this blue one's going to be number 2. Right here's a perfect point. If I continue, so is this one right here, the one where they cross at. So my slope triangle is I'm going right 1, and then up 1, 2, 3, 4, 5. So my up is 5, and my right, my over is 1. And then where is it crossing the y-axis? The blue line's crossing down here at -5. So my plus b is -5. So these two lines are perpendicular. And what do you notice about their two equations, about the slope in their two equations? Are they similar at all? So they're sort of the same. They're the same numbers. Look, they're both a 1 and a 5. Except this one, the 1's on top and the 5's on bottom, and then this one flips it over. And then this one's negative and this one's positive. So the word reciprocal is a big word that means flip the fraction. So these two are considered reciprocals because it's the same numbers, but the fractions flipped. So for perpendicular lines, the slopes are reciprocals, meaning their fractions are flipped. But they're not just reciprocals because it's not just the flip fraction. They're also different signs. This one's negative and this one's positive. And so when they're different signs, they're called opposite reciprocals because they're different signs. So this is always true about perpendicular lines, is that the slopes are opposite reciprocals. Which means if they say create the equation of a line that's perpendicular to this equation, what the word perpendicular tells me is that my new slope is going to be the opposite reciprocal of 1/3. So if I take the fraction 1/3 and I flip it over, it becomes 3/1. And the opposite of positive is negative. So this is going to be my new slope for my equation. So my equation is going to be y equals 3 divided by 1 is just 3, so it's -3, x. And then because they didn't give me a point to go through, I could pick any b I want, like maybe +2. And now these two equations are perpendicular. To show you 1/3 x plus 5 versus -3x plus 2. If you look at this cross, it is a perfect cross. They are crossing each other in perfect little 90-degree angles. So they are perpendicular to each other. The only difference is that sometimes they might give you a point it goes through, which means, first of all, it's the same equation. It's still 1/3 x plus 5, which means the new slope is still the opposite reciprocal of 1/3, which means it's still going to be -3 divided by 1, which is just -3. But now I have to solve for a specific b. I just can't pick one like up here because I have to make sure it goes through the point -2, 2, which means when x is -2, it has to equal 2. So -3 times -2 is +6. And then how do I solve for that b? By subtracting the 6 away. 2 minus 6 is -4. And that's what b is going to equal because the 6 minus 6 eliminates and becomes 0. Which means the answer is that y equals -3x and then -4 for that b. So then if I graph this one specifically where it's -4, it's still anything with the -3x is going to be perpendicular, but the -4 is going to force this line to go through the point -2, +2. Which is what they wanted it to go through. So the only other thing to mention is when you have equations that have a slope of 0, like f of x equals 5. The reason why the slope is 0 is because there is no x's, but it's still plus the 5 at the end. So there's a y-intercept at 5, but there's no x's. This is what the graph looks like. Flat line at 5. So there's a y-intercept at 5, but there's no slope. It's not going up or down. It's just kind of like a flat line. Because it's staying 5. Like the 5 as the y never changes. All these points have the y being 5. You see how they all say comma 5 on it? So if I want to make a line parallel to it, that's really easy. That's y equals any other just number, like y equals 4. See? They're parallel. They'll never cross. Never, ever, ever. So for parallel lines, it's y equals c being any other number. For parallel lines, the slope had to be the same. It had to be 0x. So as long as there's no x values written there, it's going to be parallel to it. But for perpendicular, you take that 0 and you divide it by 1 to turn it into a fraction. And then you do the opposite, which is negative, and then reciprocal, which is where you flip the fraction. So they're saying my slope should be 1 divided by 0. However, it is quite impossible to divide anything by 0. Look, it says it's undefined. You cannot do it. You cannot divide by 0. So a line perpendicular to a slope of 0 is not a function. The answer to this ends up being something like x equals 1, because then it goes this perfect up and down line and creates this perfect cross between the red and the blue. But this isn't a function because you can't have x having multiple y's. Like you can't have points on top of itself and still be a function. Which is why you can't actually figure out the slope, because there is no slope, because this isn't a real equation. And that's all. So, using if-then statements, the word linear, slope, y-intercept, parallel, and perpendicular. Explain what you learned how to do in this lesson.